So we're going to do a two-source problem, and we've been given the scenario that someone has incautiously set up a sound system with just two speakers. Here they are, they're 2 meters apart. The frequency that these speakers are producing, they're just producing a single note because that's never annoying at a party. They're producing a single frequency of 600 hertz. And we're told a variety of things about the scenario, but the things we're looking for are what is the wavelength of the sound, given that the frequency is 600 hertz. And we're looking for this point here, P. We're told that as you walk past the speakers, you notice that it goes loud and soft and loud and soft. And you're told that P, which I presume is like where you're hanging out with your friends, is the second loud point past the centre. So we know that point P is the second, so it's going to be n equals 2. So I'm not going to write all that stuff down because we're going to solve some problems with it. So first, we're going to find the wavelength. Second, we're going to find how far do you have to walk to reach point P. So let's start with finding our wavelength. We're going to use V equals F lambda. We know that F equals 600 hertz. We're going to assume, it hasn't been told to us explicitly, but it will be in your exam if you're asked this, we're going to assume that V is 330 meters per second. That's the speed of sound in air, and we're going to work out the wavelength. And if only I had thought to make these numbers nicely divisible by one another, I wouldn't even have to get my calculator out. 0.55 meters. Okay, so far so good. So we've got this wavelength, 0.55 meters. Now we want to find where P is, remembering that P is the second loud point. Okay, so at point P, n equals 2. Okay, we know that the wavelength is 0.55 meters. We know that that D is 2 meters, and I just realized there's one thing we didn't get told that we needed to be, which was the distance from the point sources to the screen. So I'm just going to tell you now that that distance there, that distance L, is going to be equal to, say, 6 meters. Okay, 6 meters from the speakers. So we've got all the things we need to find X, okay, how far it is from the centre point to point P. So we're going to use our nice two-slit formula. And because it's a node, antinode rather, we're going to use n lambda equals dx over L. Okay, I'm going to just stick my numbers in and calculate it because, as you can see, I'm running out of room a bit. So it's going to be 2 times 0.55 equals 2x over 6. And I'm not worrying about the points because I'm running out of room. So x is going to be, and I'll just get my calculator, 2 times 0.55 times 6 divided by 2, 3.3 meters. Okay, I think I've done all that calculation. 2 times 0.55 times 6 divided by... Yep, I'm pretty sure I've done the maths right. We have to walk 3.3 meters to get to that second loud fringe. Obviously, if this was a light problem, this would be much, much smaller. So would D. We wouldn't see this if D was 2 meters. So if this was a light problem, obviously the wavelength would be smaller, D would be smaller, and this X value would be smaller too.